In continuation to my videos where I intend to help you understand the interpretation of various hypothesis tests, welcome to the next set where I intend to help you understand the one sample t, two sample t and one way ANOVA test. Let me take you a step back. So when your y is continuous data and x is discrete data, one of the preliminary questions that you must answer for yourself is whether your concern area is centering or whether your concern area is variation. Should you be concerned about the centering of your problem? You must check whether your y is normally distributed or not. Should your y be normally distributed, you have the option of one sample t, two sample t and one way ANOVA. A one sample t test is done when you seek to compare the mean of a data to a standard. I have collected, let's say for instance, I am a car manufacturer and I am publishing that the car that I am producing is giving customers a mileage of 20 kilometers per liter. I may want to conduct test runs of the made cars, and I would want to check whether the mean of the population derived from the sample mean is equal to a 20 or not. 20 because that's my target. Alternatively, should you have collected attendance data or login hour data for your team and your organization has a target, let's say that a particular organization has a target that all its employees should be working for 8 hours minimum in the office. You've collected data for the time spent in office by every employee. You would want to compare it against a target of 8 hours. Then you're doing a one sample t test. Let's look at Minitab on how to do this. If I were to go to stats, basic stats and one sample t test, one sample t test has two things that it can do for you. If I were to just pick up data first, let's say total breakage. If I were not to give it a target right now, if you see, if I were to click this and give it a target, it will compare against a target. If I don't click this and simply say OK, you would see that it publishes for me the confidence interval of the population mean. So having looked at the data, I can see that the population mean of breakage will vary from 11.07 to 11.78, which may be used for several purposes. If you are looking at doing a baselining exercise, this could be meaningful information for you, so that you could easily now say that having looked at that sample, the population mean is likely to lie between 11.07 to 11.78. So if you were to do a target setting for your team, you could use this. You could give them a target of either 11.07 or 11.78 or anything between this. Should you be doing a Six Sigma project? You must understand that your Six Sigma project goal statement must exceed the confidence interval. So if I am to do a Six Sigma project on improving the mean of my breakage, I must ensure that my target is less than 11.07, because in breakage case, lesser will be better. So your current performance is 11.07 to 11.78, so you cannot have a target between this. You can't have significantly improvement while still doing the same thing. So your goal must be below 11.07. Similarly, the same one sample t test will be used in the improve phase of Six Sigma to validate whether your goal has been achieved or not. And if I were to give it a target, I would, let's say my organization wanted me to give wanted a mean of 10 kilograms. That's my target. My breakage should never be greater than 10 kilograms. Evidently, when I will put 10, the test will fail. It will say alternate hypothesis. It will say alternate because if you can see the numbers of confidence interval here, the mean of breakage is between 11.07 and 11.72. So any value between that will be null. Any value greater than that or less than that will be alternate hypothesis. obviously the p-value is 0.000, meaning that the mean of the sample is not equal to the standard, right? I'll do that again for you. I've given it a target of 10. If I were to give it a target of, let's say, 11.5, it will become null hypothesis. Yes, the p-value is greater than 0.05 now, because my chosen value is between 11.07 to 11.78. I hope this simple video on interpretation of results coming from a one sample t-test is helpful. Please understand, confidence interval is the critical element here. I hope this simple video helps you with interpretation. Thanks.